Okay, welcome back. This is part 2 of Objective 155, and today's objective is students will be able to write the degree of polynomials and put in correct order. Okay, go ahead and hit pause to get this down. Okay, I'm going to keep moving. Again, you should not continue writing this as I move on, because then you're not really listening to what I'm saying. So make sure that you hit pause, finish writing that before you let me keep moving on to the next part. All right, I'm actually just going to go on to a new slide. So last time we learned a lot about just naming polynomials. So different types of polynomials were monomials, binomials, trinomials, and then anything with more than 3 terms, so meaning 4 terms or more, was just called a polynomial. Okay. In this lesson, we're going to learn about degrees. We call them degrees of a monomial. Okay. Actually, this one, I apologize. This should not be plural. It should just be degree. So degree of a monomial. Okay. All right, here's what this is, and it's really, each word is really important in here. Okay, the degree of a monomial is simply the sum. We know sum means what operation? It means add. Okay, the sum of all the exponents, cannot spell tonight, all the exponents on all the variables. This is so important that you double underline variables. Okay. Let me give you a few examples. So what if you have like 3x squared y z to the 4th? Okay. Well, what are all of the exponents in this? Well, you have actually a hidden 1 right here, right? All numbers have a hidden 1 for an exponent, okay? But we want just the variables, okay? So we are just going to look at the variables. And what are the exponents? So again, the sum of all the exponents on the variables, okay? So what are all the exponents on the variables? Well, we have a 2 and we have a 4. Now the most common mistake, and please don't let me trick you on this, what else is an exponent on the variable? You should be looking at the y. Hopefully you already wrote this in. That y has a hidden 1 too. Okay? So what's the sum of all of the exponents on the variables? Well, you have 2 plus 1 plus 4. So what is the degree of this? The degree of this monomial is 2 plus 1 plus 4, which is 7. Okay, so if it asks for the degree of this monomial, your answer is this. The degree is 7. That's all you would have to write. Okay. I'm going to move us on because we're actually going to go back to that table that we created yesterday and fill in the rest of the table on that. So I'm going to move us on to this thing, which is the degree of a polynomial. Polynomial. And you guys are writing this with me. Okay, degree of a polynomial is, and it's actually really simple, but I'm going to give you a technical definition. It is the greatest degree of, greatest degree of the terms. Okay. Let me give you an example. So let's say I have this polynomial. Let's say I give you negative 2r to the 8th s to the 4th, and you guys are getting this down with me, plus 7r squared s minus 4, let's do r to the 7th, s to the 6th power. Okay, get that down. Okay, so if we want to find the degree of each monomial, we simply, this is almost very similar steps to combining like terms, right? Well, what is the degree of this first monomial? Okay, the degree is you have 8 plus 4. So what's the degree of this monomial? The degree is 12. Okay, on this one you have 2. Do not tell me that is 0. There's a hidden 1 there, right? So 2 plus 1 is 3. Okay, and then for this monomial, you have a 7 and a 6. Remember, am I paying attention? Am I counting these hidden 1s on the numbers at all? No, they're there, but to find the degree of each monomial, we don't care about those hidden 1s. Okay, so the degree of this monomial would be 13. Okay, so this is, I just found the degree of each monomial, right? Like we just did on the previous page. But to find the degree of the polynomial, okay, we simply take whatever one of these is biggest. So which one's bigger, 12, 3, or 13? Okay, the answer is 13. So all I want us to put for this is just a really important key point, and that is simply take, let me erase that. Simply take whichever degree is the biggest. Okay, so the degree of this polynomial, okay, and let's just write that degree of, I'm going to abbreviate, degree of poly is equal to 13. So you guys, these should be easy points on the ACT, but so many times students just forget these little things that they miss easy points on the ACT. Okay, so if it asks for the degree of the polynomial, you simply find the degree of each term or each monomial, okay, like we did here, and then you simply take, well, whatever one is the biggest, and that's your answer. A common mistake on this is because students are so used to adding these degrees up, so they're like, oh, 8 plus 4 and is 12, and then the 2 plus is 3, so they're so used to adding these exponents or degrees up that then at the very end they do this. They do, and I'm going to write it in red because this is just so wrong and such a common mistake, is they do this, 12 plus 3 plus 13, and say, oh, my degree is, what would that be, 15, 25, 28? My degree is 28. Okay. No, you do not add these up. You take the biggest one. That's your answer. Okay, do not forget that key point. All right, I think before we go on to order, I'm going to rewrite some of the, so go back to your table now that we did in the part 1 video. We had a table on a full page and we had several examples. I'm going to rewrite some of those examples, and now we're going to talk about the degree of monomials and then the degree of the polynomial. So basically we're going to fill in the rest of that table. So flip back in your notes now to that table that we started in part 1 of this video. Okay, I just rewrote the table that you guys started yesterday. I shorthand all of mine because you guys should already have like this name and term and name. You guys should already have that in your notes, so I'm not going to go back over that. So let's go over this first part, applying what we learned today. So let's focus on the degree of terms. Well, if we look at each of these terms, and we said that there were 2 terms in the part 1 of the video, okay, what's the degree of this 2x term? Well, we only take the exponents on the variables. So the only one here is a hen 1. So the degree of the first term is just 1. Okay. What's the degree of the second term? Well, you have a hen 1 on the y, hen 1 on the z. Okay, if you didn't write those in already, make sure that you do that. Okay. There's also a hen 1 on that 3, but when we're finding the degree, do we care about the 1 on the numbers? And the answer is no. So we only add up these two. So what's the degree of the second term? The answer is 2. Okay, so what is the degree of this entire polynomial? The answer is simply take the biggest one. Okay, so this 2 is the biggest one. Okay, so what's the degree of the polynomial? 2. That's it. And that's it. All right, this second example, we already said that the name of it, it's none, right? There's no name of it because of this negative exponent. Okay, if that's the case, we don't even say that there's a degree of the terms. We don't even say that there's a degree of the polynomial because it's not even named a polynomial. Okay? Now, this next one's really, really tricky because we said that there is, well, we know there's a hen 1. Whenever there's not an exponent, we know there's a hen 1. Okay, we said that this term, there's one term, right? We said that the name of it is a monomial. I'm just going to write mono. Again, you should already have this in your notes. Okay. Now, here's a key. What is the degree of this monomial? Okay, to find the degree, we only take the exponents on variables. Okay, so what's the degree of this? Well, it doesn't have any variables with it. So the degree of this one, of any number, is 0. Okay, and this is really a key point where, let's get this down because otherwise we're going to forget. Key point, okay, is that the degree of a number is always 0. And the reason why, right, is because its degree is only the exponents on variables. This doesn't have any variables, so it's got to be 0. Well, if it only has one term and the degree of the term is 0, then the degree of the polynomial is also 0. Okay. Now let's look at this next one. I'm going to make my line dip down a little bit. Okay, 4, remember we had to simplify this one. Okay, so 4a squared plus 6a plus 9. What's the degree of the first term? Well, the first term is a squared, so it's a degree of 2. What's the degree of the second term? The answer is 1, because it's a to the first power. There's hen 1. What's the degree of 9? The answer is 0. Okay. So the degree of the polynomial is simply take the biggest number. Okay, so the degree of the polynomial would be 2. That's it. Okay. Go ahead and hit pause and do this next one on your own. The 3a plus 8ab minus 12a squared b. Actually, I'm sorry, that should be I looked back at my notes, that should be plus 2a squared b. Okay. Go ahead and do that one on your own. Fill in the degree of each term and the degree of the polynomial. So hit pause now. Okay, so we have, let's see, separate. So the degree of the first term is 1. Degree of the second term, you have an a and a b, so that would be 2. Degree of the third term, you have a squared and b to the first power, so that would be 3. So what is the degree of this entire polynomial? The answer is 3. Just take the biggest one. All right, this last one, we already said that it's not a polynomial, so therefore we don't say it has a degree of a term, and we don't say it has a degree for a polynomial because it's not even a polynomial. Okay? All right, one last quick thing is order. So let me start a new slide, and then let's talk about order. So you guys can go back to your notes that we were just taking before this table on part 2 of this lesson. Okay, let's talk about 2 types of order that we may see. First one is called ascending order, and these words apply well beyond math. Okay, ascending order means that you go from smallest to biggest. Okay, that's ascending. Okay. You know, if you think about like mountain climbing, you sometimes hear people say like they're going to try to ascend to the top of the mountain. That means that they're climbing up the mountain. Kind of you start at the smallest and go up to the biggest. The other one, and we're going to focus more on this one because this is a standard form that we use, is called descending. Okay. And let's put a note here that we use this one, because that's really important. That's why I'm not even going to focus too much on the ascending. Like if you have a descent down the mountain, you are descending down something. That means that you're starting at the top and going down. Okay, so this is from the biggest. This is from biggest to smallest. Okay. And we should also put a note that this is by degree of each monomial. And by degree of each monomial. The two things that we look at to put things in order, okay, and these are kind of two rules, and this will bring us back to when we were combining like terms. The first thing that we look at is degree. Okay. Now, if there is a, let's write this, so if tie on degree, we look at, let's just say then use alphabetical. Okay, and I'll go over a few examples of that in a second here. Okay, I'm going to move on, so if you're not done, hit pause. Okay. All right, so if I have something like a plus b squared, which is going to come first? Well, first we look at the degree. Okay, before we even look at alphabetical, first we look at degree. Okay, so this one has a degree of 2. This one has a degree of 1. So which one's going to come first? Well, it's going to be the b squared plus a. Okay, so that's going to be the correct order. Again, we go by the exponents first. Now, so that's kind of example 1. Now, example 2. What if I give you this? A squared plus b squared. Okay. Now, on this one, okay, if you look at the exponents first, it's a tie, right? They both have to the second power. Now that it's a tie, what we do is we go on to alphabetical order. So what comes first, A or B? Okay, well, A comes first. So we would actually keep it as a squared plus b squared. Okay. Let's see here. Let's go over just a few more examples. Let's actually go over that example that we did earlier today in our notes. It was this one, and you guys should already have this in your notes. I'm just going to rewrite it real quick and try not to be too sloppy. Plus 7r squared s minus 4r to the 7th s to the 6th. Okay, and we found that each of these degrees, okay, this had a degree of 12, this had a degree of 3, this had a degree of 13. So which one is going to come first? Well, the one with the biggest degree. So this 13, and make a note, okay, make a note that it's the biggest, comma, so first. Okay. Now the other really important thing is you have to keep this sign. It is minus 4 r to the 7th s to the 6th. So instead of writing minus, if I put it at the beginning, it's going to be a negative. Okay, 4 r to the 7th, s to the 6th. What came next? Well, this was next with a degree of 12. It was a negative, so instead of writing negative, I write minus. Again, a negative and a minus mean the exact same thing. 2, r to the 8th power, s to the 4th power. Okay, and then finally you have the positive 7r squared s. This is in descending order by degree. Okay, and that's what we're always going to go by. Once we get an answer, we got to rewrite it to make sure that it's in the correct order. Okay, I think I'm going to stop there for examples because we're going to practice a lot more in class. But if you have any questions, make sure you take some time, put a question mark, and write specifically like what your question is. That way when you get to class, you can ask a teammate or myself right away.